Okay, let's look at exponential functions 9.2. It asks us to graph 2 times 3 to the x, sketch the graph, identify the domain and range and any asymptotes, and then determine if it's increasing or decreasing. Okay, if it's an exponential function, the parent is y equals 3 to the x. So the table for the parent, -1 is 1/3, 0 is 1, 1 is 3. And those are the only points that you need. Well, now I can expand this and add the table on here that it is 2 times 3 to the x. So that becomes 2/3, 2, and 6. So there are a couple ways that you can do this. I'm going to plot the points of the parent. So -1, 1/3, 0, 1, and 1, 3. Okay, so there's the parent. And then really what this is telling me to do is I am going to double each y coordinate. So that means I'm going to this point, 1/3 becomes 2/3, 1 becomes 2, and 3 becomes 6. So this is my function. Now I also remember that this function has a horizontal asymptote at x equals 0. Because no matter what x is, if you take 3 to that power, it will be a non-negative number. Okay, so for your transform function, the domain is all real numbers. Nothing you can do to change that. The range, we did not shift it up or down, so it goes from 0 to infinity. We do have a horizontal asymptote at y equals 0, and it is increasing. It goes up as you look at it from left to right. Okay, if you want to sketch the graph, f of x equals 3 times 1/2 to the x. I'm going to do exactly the same thing, and if you can jump to the end if you want to. However, the parent is y equals 1/2 to the x. So my base is 1/2. I'm still going to use -1, 0, 1. Well, 1/2 to the -1 is 2. Anything to the 0 power is 1, and 1/2 to the first power is 1/2. Now, if I want to do 3 times 1/2 to the x, I'm going to multiply these by 3. So that's 6, 3, 3/2. So for my parent, I have -1, 2, 0, 1, and 1, 1/2. Once again, I have a horizontal asymptote. It will never be 0 or less than 0, my function. And so now my function becomes, I have -1, 6. Oops, and that's -2. Sorry, -1, 6, 0, 3, and 1, 1.5. Okay. So again, I did not shift it up or down. I just stretched it vertically. So that means my domain is always -infinity to infinity. My range, since I didn't shift it up or down, is from 0 to infinity. My horizontal asymptote remains at y equals 0, and this is a decreasing function. Okay. So let's see what we're doing now. All right, now we are going to look at money. Let's see if we can find the amount in an account if $1,000 is invested at 3.5% for 10 years. And we're looking at different compounding periods. Okay, so we're either looking at A equals P times 1 plus R over N to the NT, or we're looking at A equals PE to the RT for continuous. Okay, so those are the formulas that we're looking at. All right, so from here, we can tell that our initial amount is 1,000. Our R is equal to 0.035. Remember, we have to um, turn it into a decimal, and our T is equal to 10. So the only thing that we're changing on this on parts A, B, and C is we're changing the N, and the continuous, we're good to go. Okay, so for yearly, this tells us that N is equal to 1. So I have A is equal to 1,000 times 1 plus 0.035 divided by 1 to the 1 times 10. So A is $1,410.60. If it's monthly, then N is equal to 12. So my A is 1,000 times 1 plus 0.035 over 12 to the 12 times 10. Now, depending on your calculator, you might need to either put this in parentheses or just multiply it. 12 times 10 is 120. And when you do that, you get that A is 14, 18, 34. I hope those are correct because I did them earlier. Okay, daily. That tells you that your N is equal to 365. So plugging that in, you get A is equal to 1,000 times 1 plus 0.035 over 365 to the 365 times 10. And again, you may just want to change that to 3650 when you're plugging it in your calculator. So your ending amount is 1419.04. Okay, so you can see as you're going, as the compounding period, as n increases, so does the amount in your account. It goes from 1410, goes up almost $8, but now here it doesn't even go up $1. If it's continuously, your A is equal to your P times E to the 0.035 times 10, and that gives you A equals 1419.07. So you can see it's increasing, but there's 3 cents difference here. Less than $1 between monthly and daily, and between yearly and monthly, there's quite a bit of difference. Okay, the amount of polonium A after X days of radioactive decay is given by this formula where A is measured in milligrams. How much is present after 140 days? And then after 100. So 140 days means that X equals 140. So this becomes A equals 2 times 1/2 to the 140 divided by 140, which is just 2 times 1/2 to the first, which is just 1. Now that makes sense because the half-life, this tells you it's a half-life. So if you start out with 2 milligrams, after 140 days, you should have 1 left. Okay, if you have 1,000 days, that tells you that x equals 1,000. Same process. So A is equal to 2 times 1/2 to the 1,000 divided by 140. So A, I put this in my calculator, is 0.014 milligrams. Okay, if you're looking at 9.3 at log functions, the thing that you want to remember is that log base b of y is equal to x is the equivalent of saying b to the x is equal to y. So we can go back and forth between these two forms depending on what our needs are or what the question asks. Okay, so if I have 10 to the second equals 100, and I want to convert that, then I can start out and say log base 10, and I'm going to go ahead and write it out. Log base 10 of 100 is equal to 2, which is the same thing as log 100 equals 2. You will never see us write this, but to stay consistent with what we're doing. And the way that I do this is I kind of do a little around the world thing. It works for converting both directions. This is my base, argument, exponent. So my base to my argument to my exponent, this tells me that log base 5 of 1 over 125 is equal to negative 3. Your logarithm is an exponent. So the exponent is what it should equal. Okay. So I'm going to go ahead and write this out again. This is log base E of 7389 is equal to 7.389. Well, log base E is just the natural log of 7.389 is 2. Okay, so same thing here. My base, so this is log base 2 of 16 equals 4. This is log base 27 of 3 equals 1/3. And again, just continuing down. Base, argument, exponent. And a log equals the exponent. Base, argument, exponent. Base, argument, exponent. And I'll go ahead, since I'm using E, I can go ahead and write this as the natural log, whoops, of 0.3679 is equal to negative 1. Okay, I can continue on doing this exact same thing. Here, If I want to go log base 5 of 25 equals 2, I know I have a base and I have an exponent and I have an argument. But I can just also think about it in an around the world thing. So this becomes 5 to the second is equal to 25. If I have the natural log of 2 equals this number, then I can say, okay, my base is e. So that's going to give me e to the exponent equals the argument. E to the 0.6931 is equal to 2. And again, if it's in log form, what it's equal to is the exponent. Okay, same thing here. Log base 10, again, you would see this as log of 0.01 equals negative 2. That gives you 10 to the negative 2 is equal to 0.01. The base, the exponent, the argument. Okay. This tells us that 10 to the second is equal to 100. This tells us that 3 to the x is equal to 9. Since there's no base, that tells us the base is 10. So that gives us 10 to the negative 1 is 0.1. So 10 to the negative 1 is 0.1. Okay, well, if I want to evaluate the following, I want to know what this is equal to. Okay, so as I'm doing this, as I'm starting out with this, I wanted to change colors and I almost forgot. Okay. This tells me that I'm looking for 2 to what power is equal to 1 over 128. Well, let's see. 128 is a power of 2. So 2 to some power equals 1 over 2 to the 7th. So 2 to whatever I'm looking for is equal to 2 to the negative 7. So my answer is 7. Okay, so if I want to do log of 100,000 divided by 100. Okay, well, I'm going to change this to the log, and I'm going to cross off a couple of zeros here. So this is a log of 1,000, and I want to know what that's equal to. So 10 to what power is equal to 1,000? Well, 10 to the third is equal to 1,000, so the answer is 3. Okay, so if I'm multiplying here, of course, I can turn this into a single, so the natural log of e to the 5x plus 3x gives me the natural log of e to the 8x which is just 8x. If I have log base a of a to the ninth over a to the second, I can start out by writing this as log base a of a to the 9 minus -2, which becomes log base a of a to the 11th, which is 11. Remember, the rule here is log base b of b to the x is equal to x, because you're looking for the exponent. Okay, so I'm looking for 8 to what power is equal to 2? Okay. Well, I know that 8 is equal to 2 to the third equals 8. And so if I take the cube root of both sides, I get that 2 is equal, I'm sorry, and that's the cube root. The cube root of 8, or 8 to the 1/3, so my answer here is 1/3. 8 to the 1/3 is equal to 2. Okay, and this is another one of your rules. If you have b to the log base b of x equals x. So if I have b to the log base b of 2x plus 7, then the answer is 2x plus 7. Okay, we'll stop here.